Hi again. We're going to do one more piece of new content, and it's not going to be very different from what we did last time, AP2 children. And then we'll just do review the rest of the week, getting ready for our final next week. And I will give you some practice questions, and we'll work to review. Don't forget that I'll see you RTI. I can see you tonight at 8. I'll see you RTI on Monday, Wednesday. Or you can make appointments with me, and we'll work like that. So, we're going to do thin lenses. And thin lenses, we have two basic types, converging and diverging. Just like with mirrors, we had convex and concave. Diverging. There we go. So a converging lens can be one that has a convex part. The most common are double convex, so they bow out on both sides. But you could have plano convex is what we call that, or you could have a meniscus. It's called a meniscus. I left off the C. And it would be converging if this is the way you start. You start on the convex side. This is called plano convex. Flat on one side, convex on the other. And this is a double convex. Double or biconvex lens. Okay, the diverging lenses are going to be your concaves. So you can also have a meniscus for this. But this time you'll start in the concaved side. So this too is known as a meniscus. We can also do a plano concave. Oh, that's terrible. Forgive my bad drawings today. I'll try to do better. It goes out like that. And then you have the ever popular double concave, which looks sort of like an hourglass actually. So this is plano concave. And this is biconcave or double concave. So we're going to talk about these two. Now, what do we have to know about light going through lenses? Well, first of all, instead of a mirror light bouncing off, light is both reflected and transmitted through a lens. Light is both reflected and transmitted through a lens. So as soon as the light hits the lens itself, some of the light will bounce back, and some of the light will pass through. The tricky bit for this, of course, is that when you're doing this, we're mostly working with objects that are transparent. So lenses are transparent, which means most of the light transmits and only a little bit of it gets reflected in the ways that we're using it for this class. So, reflected and transmitted. And we're still going to have our three. This time we're really going to use the three principal rays to find the images. These will be the same rays that we did with mirrors. We're just adding one. First ray, central ray. Second ray, parallel to the primary axis, to principal axis. That's a principal axis. And the focal ray. And this, as we did last time, focal ray will go through far side focal. Well, let's leave that alone. Let's talk about this before we do those. Let's draw the picture so you can see where they're going to go. It will come out, it will be parallel. So it's still going to be a parallel exit. This one will be a focal exit. And this one will be unchanged. So these are our three principal rays. Now, let's remember some things. And let's state some things about what these thin lenses are going to be. Number one, these are thin, meaning refraction is ignored. So the bending of light is basically ignored when we do this. Lenses, they're too small for us to worry about how the speed of light changes in the medium. And that's what happens when we're doing refraction. Refraction, the speed of light will change depending on the material it's in. And so that causes images to form differently. These are thin lenses, so we're going to ignore that. In your glasses that you use for the eyes, that's probably not entirely true. Plate glass, it's not always true. So there's some things you have to pay attention to. So that's our first assumption. We're still going to have virtual is still going to mean no light actually went there. Let's say it like this. Reflected light might have gone there. This is reflected, not transmitted. Real is going to be the light that is transmitted now. We are now going to have two focal points. Which is going to cause some differences. But then the math, you're still going to use 1 over f equals 1 over object distance plus 1 over image distance. Whoops. Image distance. And we're still going to have that magnification is negative image over object, or magnification is height of image over height of object. So all the math you did with the last piece is going to be exactly the same except for the way we use the signs. So that's going to be the big difference here. So I'm going to draw you some of each type, and then I'm going to give you, you'll have some time to practice on these and ask questions. Hopefully you'll see me tomorrow, or I'll see you. I'll be there. And then we can take some questions. So let's start with this. Let's say that we have, here's our first example, and we are told it's a converging lens. Converging lens, focal distance is 8 centimeters. So how's AP going to show that? AP is going to show it like this and tell you it's converging, or at the top and bottom they will make these little arrows. This means the lens converges because it bows out on each side. That's what they're trying to show you without actually drawing a thick lens, because we're treating these all as if they're very, very, very thin. So a converging lens will have the arrow tips to indicate. So let's go ahead and put an object up here. Let's, for argument's sake, as we always do, use an arrow. I'm going to use an, come on. I don't need a big thick arrow, I just need one good arrow. Here's my arrow, and let's make that at 15 centimeters. And let's make this focal point 1, focal point 2. We're going to draw our ray diagrams for converging lens. So here's what happens. As we did, we're going to start at some particular point on the object, and I usually pick the top point, and we're going to draw a ray that goes right through that center point. And of course, I need to make this, make it red, I'll make it heavy, not that heavy, that heavy. That'll do. So there's one of our rays. That's the central ray. Okay, I'll do all my central rays in red. You'll notice it goes straight through the middle and it doesn't get changed. It doesn't deflect, it doesn't bend, it doesn't do anything. Okay, now our focal ray is going to go through the focal point, and notice it's going to go through the near focal point. Okay, through the near side focal point. And then it's going to, let me get the weight right. You're going to be blue. And you're going to be heavy. When it gets there, the next thing that's going to happen is we're going to do another line. Let me get this one off. Oh. Wow. Okay, computer, just fritz out for a second. The next line is then going to start at the mirror, at the lens, sorry, and it's going to go out parallel to the central axis. Once again, make it heavier, and it's blue. Okay, so it came in through the near side focal point, went out through parallel to the central axis. Okay, or to that principal axis. So this is our focal ray. And then last but not least, we're going to have, let's do it in a loud, what color should we use? Yeah, this is a hot pink. The last one is going to go in parallel. That's going to be our parallel ray. I'll make him purple. Okay, parallel ray, as we state before, is going to go in parallel. Color will be more colors. I want purple. And I want it to be heavy. So it goes in purple, hits the mirror, it's parallel. Let me change that color. That's too close to the other one. There we go. Okay, then once it gets there, it's going to go out through the focal point on the far side. Okay, so here we go, making our line. It goes through the focal point. Whoops, that was supposed to be a line, dear computer. Insert shape, line. Goes through there. Purple. Shape size. And a half. And so now you can see, hopefully, better than drawing it by hand, that the tip of the arrow now will form here. So where the tip was here, now the tip is here, which means my image will be upside down and smaller, which I can see pretty easily on this picture that we've got. So the first thing we're going to do is practice doing those drawings, and this is our parallel ray. So what are our rules for converging? Central ray goes through Object and center of the lens unchanged. Focal ray goes from object to nearest focal point to lens and out of lens parallel to principal axis. Last but not least, parallel ray is through object parallel to axis to lens, then out from lens to the far side, to the far focal point. And then of course we'll have to be able to calculate these, and we'll have to find sizes and all that. So we've got that for this problem. So I'm going to move up here to the top right hand corner. We're going to classify it. Did the light go through the lens? Are the light rays actually going through the lens and the image is where the lens is? Yes. So this is a real image. Light went through our image. It's a real image. It is also, if we look at it, it is closer to lens. It is upside down, inverted, and it is smaller than the original. Smaller than the original. We can see all that. So let's do the math to justify it real quick. Thanks, notifications, for popping on the screen. Alright, so let's do the math. What's going to be the positive side and what's going to be the negative side now? Well, for a converging lens, we expect light to go through the lens. So for a lens, the positive side is opposite of the object. The negative side is on the same side as the object. In other words, we made the math the math works the way it is because with a lens, the light should pass through the lens. We expect all the light to go to the other side of the lens, so that we'd need to be standing on the other side of the lens to see the image. Just like when we have glasses on. Your eyes see the image that forms behind the lens because the light comes through from outside through the lens into your eyeball. So we call that the positive side. We don't expect the light to bounce back off the lens and make an image behind us. That would be weird. Some of the light does actually do that, but very little of it in a lens does that, and so that's why that is partly given that negative sign. Also, the way the math works, it works better if we do it this way. It makes more sense. So here we go. Number 1. Is our focal point positive or negative? Well, our focal point is on the same side as the object. So there we go. Our object is on the same side. And our image in this case is the eye. So, here's how we're going to do that. What are our sign conventions going to be? For converging lens, focal is negative. Object is. So 1 over, I just copy in my numbers, okay, 8. 15 plus 1 over Q. Once again, I'm going to use my calculator to get those numbers. So this is negative 0.125. We will subtract you know what? I better check that. Okay, so I'm going to show you this so that you can see what's going on. Okay, so we're going to put our, it depends on what kind of image we're using, what kind of object we're using, and I was setting it up. So your image and your object, as you can see, are both on the left of basically a convex piece. Okay, and since that's on a convex piece, that makes your focal distance and object distance, if this was your image, okay, this was your image, then your image would get a negative sign because it's on the same side as the object. In other words, the light didn't go to the other side like we expect. So for a convex lens, the object and the focal distance will have the same sign. The image will typically have the opposite sign. Okay? For concave, that's going to be different. So let's go back to our picture. And let's go back to this. Negative 1/8. Oh, I didn't do it over there, did I? This is negative 1/15. So it's going to become plus when I move that little sucker over. Sorry. Let's go back and make sure I say this right, because they write it in a way that I don't like to use. I don't like to use this particular formula. I like to have them just like the lens maker's equation, and that's what our book shows as well. So for our convex lens, the focal distance is going to be positive, but our object's going to be negative. So here we go. This one is positive. Because they're on opposite sides from each other. Okay, so negative 0.125. Give myself more space. Here we go. Start over. 1 over F equals 1 over P plus 1 over Q. So this is 1/8 positive equals 1 negative 15th negative plus 1 over Q. Sorry about that. So when we do these, one way to think of it, and I think some of my students have given this the idea, is that they think of the origin, you know how we have the XY axis? They think of the lens being here. This is to the left, so it gets a negative sign. This is to the right, so it gets a positive sign. The trick with that, though, is if you put your object on the right-hand side, then your signs will be opposite, and that's a little confusing. As long as you're consistent, you're going to be fine. So this is 0.125. And this will be plus, what is 1/15th? I have to figure that out real quick. 0.067 equals 1 over Q. So I get that plus 0.125. And I get, whoops. 0.192 equals 1 over Q. So Q equals the inverse of that. It's 5.2 centimeters, which is what we expected. 5.2 centimeters. It should have been in here, but of course my graph is not drawn to scale. So it is closer. It is on the other side. If we do the magnification or we look at the picture, we can see that it is also upside down. So there's your converging lens. Now let's do a diverging lens, and then I can make another video if you guys need some more practice on things. We can talk about that tomorrow. Well, today, Monday for you guys, Sunday for me. Whoops. And you'll find, what you're going to find is that the converging lens acts like the convex mirror, and the diverging lens acts like the concave mirror in terms of their ray diagrams. So let's do a diverging mirror. Lens, sorry. Okay, so now focal is negative. Object is negative. Let's see how we do this. So here's our, let's draw us a nice straight line. Nice straight line. Let's make it black. Let's make it some white. Okay, and then we're going to draw another line. Wow. So we're having the fight with the computer day. There's our lens. Now, to indicate that this is a diverging lens, what they're going to do is they're going to put two little feet like this to indicate that your mirror looks like that. So it caves in on both sides. So this is your sign that it's diverging. Or they will tell you in the problem that it's diverging. So now let's pick an object. Here's my object. Here is, let's do focal points out here this time. Focal 1. That's not far enough, is it? Focal 2. Alright, I feel good about this. Now let's do our ray diagram. So here we go. Central ray. Central ray comes through the tip, goes through the center, comes unchanged. I have to adjust this on each side till I get it tip and center. That is our central ray. Okay? Give it a little bit more weight. Now, let's insert our parallel ray. So parallel ray is going to go to the mirror. Parallel. And then when it hits the mirror, the next thing it's going to do is it's going to go through the focal point. But this is a diverging lens. So the focal point we're going to be working with is going to be the one on the same side. Okay? So let's insert our line. And it's going to appear to, I have to, my goodness. Computer's fighting me on drawing these pictures today. It's going to go through tip, through here, out there. I'm going to need this to be a little bit taller. Okay, so let's fix this a little bit. And let's home. Let's insert. Let's talk about you. See if I can pick this up. There we go. Sorry guys. Video's going to take forever because I got to get the stupid thing to go up high enough. Okay, now we're good. Probably should do that on the bottom as well. And then I'll redraw those indicators. The indicators look like greater than or equal symbols. Okay. So, when that one hits the lens, the next thing it's going to do is it's going to come out. So here's what's going to happen. This one, when it hits the mirror, good gracious, it's going to hit the mirror and come out parallel. Okay? It's going to come out there. And once again, we're going to give this some more weight. Those two like they're supposed to. That one's going to come out parallel. Let me get this one. Bit. Oh boy. Okay. And then this last one, the one that comes in parallel, is going to go out through the focal point. Hang on just a second. This is all screwed up. Okay. The one that comes in parallel, just give me a stinking line. Insert a line. Thank you. Make it be orange. Make it have weight. Aim it from this focal point tip this up. So what we've got is the parallel ray is going to appear to come out through this focal point. So what I'm going to have to do is I'm going to have to get this sucker lined up so that it goes through there and through here. And so I'm going to draw some arrows real quick to kind of help with that's happening. So the ray comes in here, goes through the lens and goes out there, but this piece is where it appears to have come from, just like we were doing with the mirrors. This is the back traced ray. And then this is where the light actually goes. Now, for the final ray, this one is a little interesting. The final ray is going to be sort of the same idea as the other, but we're going to aim at the focal point. I'm going to get me a big line here. It's going to go from the tip through that focal point, the opposite side one. It's going to go through the tip, but it's only going to go through the tip to the mirror. Let's get that one some lovely shade of something. Let's give it, once again, give it some weight so you can see it. So this is your focal ray. I aimed, excuse me, I aimed at the focus. I aimed at the focus, but then when I come out, I'm going to come out parallel. It's going to come out parallel. Black. Have weight. And there you go. So this is our focal ray turns into parallel. Focal ray turns into parallel, just like parallel turns into focal. Okay? So now your question becomes, where do those three images then, where do those three lines intersect? Well, you can see that over here we get no intersection. That's why it's called a diverging lens, is because the light spreads out on the backside, which means we have to look at back tracing, which would be here, here, and then the central ray, which is this guy, we have to see where all three of those intersect, and it looks to me like it's going to be maybe a little further over. Right in here somewhere. So this will be our image. This is the harder one to deal with because you have to pay attention to what happens. So our order of these is the central is just the same. Central goes object, lens, out. Parallel goes object, lens, near focal, out. So it goes object, lens, there's your parallel piece, and then near focal, out. So you have to back trace that one. Focal goes near focal, object, lens, out parallel. And yes, you're going to back trace these. So let's do the math here. 1 over F equals 1 over DO. It's 1 over DI. Let's give some numbers. Let's make the focal distance 20 centimeters. That's like the object is going to be 12 centimeters. So focal is negative 1/20. Object is negative 1/12. You'll notice these are both over here on the same side. Okay? So my object is positive. Objects are always positive. Guess I could just say it like that. Image, we don't know. And so we get, when we do that on this side, get negative 1/20th minus 1/12 equals 1 over di. So I'll do that on my calculator real quick. 1 divided by 20 divided by 12. Oh my goodness. Divided by 12 is negative 0.133 equals 1 over di. And so then we invert this and we get di equals 7.5 centimeters. As we can see, so we would classify this image as virtual because it's on the same side as the object. It's the reflected light, not the real light. It is also upright, same orientation. It is closer and it is smaller. And so there's lenses. You might want to watch these a few times. You might want to do more practice problems to help yourselves out. But they work very, very similar to mirrors. So be aware of that. We're not going to do a quiz just on this. We're going to do that on the test as a section of the test. And then for the final exam, and I will count it. If it helps you, we'll let you help you. Other than that, please ask questions, email me, and stay with it. We'll talk to you soon.